Now I will show how to process the point cloud to get fracture information. The first step will be to create a mesh of the surface. However, before I do this, I sometimes will want to edit the point cloud to get rid of outlier points. The trees in the background are probably not going to be a problem because it's not going to mistake them for fracture surface anyways. But sometimes in front of the scan, we get some points. For instance, maybe there's an automobile that drives by and we get some bad points. What I can do, for instance, is click the Z on the keyboard. That gives me sort of a top-down look. And then what I can do is I can select any points that are in front of here. In fact, the other thing I do is hit the Control key, line it up a little bit, and then what I'll do is I'll click on this tab here, which is sort of the editing tab, and I'm going to see if there's any points between the scanner and the rock face. And yes, you can see there's lots of points. Again, this could be from cars going by, someone walking in front of the scanner, or even dust particles or bugs in the air. So what I'm going to do now is I'll just hit Edit, Delete, and that deletes those points. And typically I'll get a better mesh that way. So I'll go back to the instrument view, and I'll unclick this edit button. So again, I can move around. And now we're going to create the mesh. So I'll come to Point Cloud, Create Mesh. The idea here is it triangulates a mesh, and each triangle has a certain size and it will contain a certain number of point cloud points. And typically we adjust the size of the mesh so that it contains somewhere between 10 and 20 points. So here I'll adjust it so it contains about 12.5 point cloud points per grid cell. I click OK. I can turn off the points, and I've left the mesh on, and now if I zoom in you'll see that this is the mesh of the surface. So it's made a surface containing all these triangles. The next step will be to look at these triangles. It'll calculate the normal to each triangle, and it finds patches that have similar orientations, and those will be our fracture patches. So I can turn off the mesh view, turn on the point view again, come to Point Cloud, and come to Find Patches. There's a few different parameters here. The most important ones are the minimum patch size and the maximum neighbor angle. And I'll just leave these as sort of the default parameters. There's also some filters that will filter out patches that contain points that are too scattered. And so that'll say OK. Now this is a rather long step. It'll take maybe 10 seconds or 15 seconds for to process all this data and calculate all the patch information. Okay, it's calculated the patch information. Now we can see that it's found a number of patches, some large, some small. It has found these large fracture surfaces, and the patches are outlined in yellow. Also, the holes in the patches are outlined in red. So at this point, we now can directly plot this on a SteriNet. So we go to Region, SteriNet View, and we can now see a SteriNet view of these patches. Now there's different ways you can show this. Basically each patch is shown as a single point on the SteriNet. Now what you can do is you can adjust the size to represent another quantity. And if I go to SteriNet Properties, Plane Orientations, you see what I've done is I've adjusted it so that the size of the point is a function of the area, and that allows me to see these patches much more clearly. You'll see that if I take that off, where each point plots is the same size, then we don't see the sets as clearly. But if I plot them as size as a function of area, then typically I see the sets much better. Now what I can do at this point is I can start to investigate these potential sets. What I can do is I can identify some patches, and then I can go back to the point cloud and look at them. You can see that that particular group of patches represents this one set. Which you can see very clearly here. So now what I can do is I can identify that as a set. I can go to Insert Set. I now isolate those patches. I can call it a set. I'll call it Big Set. It contains most of the big fractures. I say OK. And now I've created a set. Now if I go back to the point cloud view, you'll see that now in the left window I've created a set called the big set, and if I click on that, it gives me statistical information on that set. For instance, the mean orientation, the Fisher constant, and other statistical information.